Hello there, this is the daily message for Friday, July 1st. Today in class, we're going to continue looking at the idea of correlation and causation. Now, this is I think a really important topic for you to cover in this course. The reason for that is the idea of correlation versus causation gets misused or mistaken a lot in the media. In news articles, I see it all the time, on TV, and to really have an understanding of the difference between correlation and causation is an important skill to have because it will help you make better inference. Now, two of the biggest mistakes that I see when people talk about the idea of correlation versus causation is first, they get the two words confused. So recall from yesterday, correlation is purely a visual pattern we see when we plot the data. Whereas causation actually means that one thing directly causes the other. And so the videos you watch today are going to talk more about this idea of causation. The other mistake that people make is they often want to use colloquial information to talk about causation. So for example, you may have a friend who did thing A and then thing B happened. And so very naturally we want to conclude that thing A causes thing B. But really we can't do that. The only way to prove causation is through a well thought out experiment that does proper comparison and randomization. That really is the only way to prove causation. And the reason for that is that thing that your friend did, they did thing A and they did thing A and then thing B happened. That may have just happened due to random chance, or there may be a third variable at play that you don't even know about. And so that's why we have to use experiments in order to show causation. And those experiments have to have randomization and proper comparison. Now, you learned previously, if you do an experiment with randomization and proper comparison, then that helps reduce the likelihood that there's a confounding variable. Well, confounding variables are what mess up our inference about causation. That's why we have to account for them. Now, in order to show you how difficult this topic can be and how often it gets confused, underneath this video, I have a video from earlier this year from the Republican primary debate. So in this debate, you're going to see Dr. Carson and Mr. Trump speaking. Now keep in mind, these are two people that are on a national platform. They're talking to lots and lots of people, so they want to make sure whatever they say is correct. They want to say the right thing. The other thing to keep in mind is these are two well-educated people. These are not your everyday people. They are both well-educated. They have college degrees, and so we would expect them, to talk about things correctly. But what you're going to find is they have both made mistakes about the idea between correlation and causation. And that's because this is such a difficult topic that a lot of people get confused. And that's why it's important for you to be able to recognize the difference between them. So the first mistake you're going to see, Dr. Carson is speaking, and Dr. Carson makes the claim that there is no correlation between autism and vaccines. But in fact, you already saw last class that there is an association, there is a correlation there as well. What we didn't show is a causation. So I think what Dr. Carson actually means in this video is that there is no causation. In other words, we haven't been able to prove a causation between the two. But we have proved a correlation. So when you watch that first part of that video, notice that he's getting the idea between correlation and causation confused. When you watch the second part of the video, when Mr. Trump responds, what you're going to find is Mr. Trump is using colloquial information to support evidence between vaccines and autism. But again, we can't use colloquial information, and people do this all the time, and it's because it's a very natural thing for us to want to make inference about. But when really what we need to do is we have to have an experiment. We can't cite colloquial information to show a causation. And so I wanted to show that video to you. Like I said, it's a very relevant topic. It's recent from this year, and it's two people, well-educated people that have made mistakes about these concepts. And so I put that there to kind of illustrate these concepts aren't easy. They get confused a lot, and that's why it's really important for you to understand the difference between them and what inference can really be made between a correlation and a causation. Now, the other link that you're going to see at the end of today's video post is a link that I was going to provide for some bonus points. Now, in order to get these bonus points, you are going to have to send me an email. Make sure you do that from your email account, and it has to be sent by Tuesday, July 5th at 6 p.m. So what this website is this is a website that somebody has created, and this website looks at different correlations between variables that are pretty obviously not related. And so what I'd like you to do is kind of look through that website, and you're going to see a lot of different correlations, a lot of different associations that are there, but it should be pretty obvious that, you know, the explanatory variable is not causing the response. And so what I'd like you to do is to look through there and just send me an email with two that you thought was interesting, that you thought it was interesting that these two variables are correlated, but are obviously there's no causation at play there. And the reason I want you to kind of scroll through there and look is to really kind of solidify in your head, you know, you're going to see some pretty ridiculous things compared. And so you're going to see those ridiculous things compared, see that there's a correlation, and hopefully that will help enforce the idea that correlation really does not imply causation. So that later on, when you see another plot where there's a correlation, you can kind of keep in mind and be like, hey, you know, really all I'm seeing here is a pattern in the data. This does not prove that this one thing causes the other to occur. So as always, if you have any questions, you know, please use the discussion board. I'm more than happy to help out, and I hope that everyone has a wonderful weekend.